In this video, we are going to learn about the electrochemical series, what it is and how it is used. In the video, Measures of Electricity, we found out that different combinations of metal produce different voltages, and this depends on how strongly the metal could force its electrons to move across a cell. The electrochemical series is a list of metals and other substances arranged in ranked order of how easily that atoms may lose electrons. The further apart the metals are in the electrochemical series, the higher the voltage is produced across the cell. Electrons flow along the wire from the metal higher in the electrochemical series to the metal lower down. The electropotentials are arranged in the substance's ability to donate this electron, that is, how easily they are oxidized. All of the values are measured in volts. What do you notice about hydrogen voltage and what is the significance of this? Pause the video and continue when you are ready. The answer is the hydrogen has an electrode potential of 0 volts. The significance of this is that it acts as a reference. All other electrodes' potentials are measured against this value. It is a bit like the heights of a mountain, which are relative to the sea level. The sea level is given a height of 0 meters. Using the electrochemical series, can you predict the direction that the electron will travel towards the following pairs of metal? The electrons always move from the metal with the more negative electrode potential to the more positive electrode potential. Pause the video and continue when you are ready. For A, the answer is the electrons move from potassium to hydrogen. For B, the answer is the electrons move from zinc to copper. And for C, the answer is the electrons move from lead to mercury. You can also use the electrochemical series to predict a displacement reaction when a metal from the electrochemical series is mixed with ions of metal lower down in the series. The atoms of the more reactive metal push their electrons onto ions of the less reactive metal. Let's consider what happens when an ion now is placed in a solution of copper sulfate. The higher down metal in the electrochemical series is one that always displaces the ions of the lower down metal. Metals down in the series cannot displace more reactive metals from this solution. You can use this idea to predict whether a displacement reaction will occur. Here is a challenge. Can you explain why the ion now from the copper coating when it was placed in the solution of copper sulfate? Pause, think, and continue when you're ready. The correct answer is that the ion is higher in the electrochemical series, so it gives away its electrons to less reactive copper into ions in solutions. The ion is oxidized as shown in the equation. The copper is less reactive, so it is Cu2 plus ions and forced to accept these electrons. This is called reduction. As a result, copper metal is produced and coats them. Now, as shown in the reaction, these two processes happens simultaneously in something called a redox reaction. In summary, the electrochemical series contains electrode potential which measured in volts, which are compared to hydrogen. The greater the difference between the two substances in the electrochemical series, the more readily the electrons move from the more reactive metal, that is, the more negative value of the less reactive metal, that is the more positive value.